Greetings and welcome to this installment of Introductory Solid Modeling with SolidWorks. This is the final video for the Crescent wrench project. In this video we will assemble this thing. We already made 4 parts. The main handle here, the worm gear, the set screw, a little bit harder to see there, and the adjustable jaw. So in this one, we will start with the handle, make sure that that is aligned to all the planes in the assembly file. And I think this time I'm going to put the set screw in first, and that should be pretty easy, just going right in that hole. The worm gear will go around the set screw, and we will do our best to make it nice and even in the middle of this cutout here. And then finally put the adjustable jaw in. Part of it should be pretty easy, going right with the parts of the handle, but then making it mesh nicely with the worm gear hopefully won't be too much of a challenge, but it should be interesting. After that, we're going to make a motion study out of it so we can watch it move. Here are my parts, and the next thing we need to do is open up a new assembly file. I do that by simply going up here, going to make assembly from part assembly, hit OK, and these are the ones that we had open and available, so it asks if we want to use that. So first I'll click on Crescent Handle Example and then just click right in here. Now notice how this comes up again with this F here. I want to put it in there in a particular location. Let me at least explain to you why. If I go up here to my assembly section view and I click on it, they have the default of the front plane, the top plane, and the right plane. But they don't match up at all with what I wanted to be the top, front, and right planes. So as I try to move these back and forth to check the cross sections, they just don't work out. And it doesn't even show up here until I move it. There we go. So to get out of that, instead of making it fixed, I'm going to make it float. Then I'm going to make some mates. So I'm going to mate up the different planes. Front plane here, front plane there, top plane there, top plane there, right plane there, and right plane there. Okay, now when I do my section views of front plane, top plane, or right plane, they come up exactly where I had intended them. And then it'll be the same for all the rest of them as I assemble them with respect to the handle. Okay, so I'm going to insert the set screw next. And I didn't do it quite the right way that I wanted to, so it's not pointing quite the right direction. But I'm going to go to View, Temporary Axes, and zoom in here. I've got an axis here. I'm going to mate that with this axis here. Going to make them coincident, but I want to change the alignment. I'm pointing it the wrong direction here. So, that makes a lot more sense. And then, not quite sure exactly where this needs to go. So I'm going to go to this. Okay, click that, then move this back and forth to see how far in it gets. And I'm figuring that my threads are going to bottom out right around here. So I'm simply going to I'm going to undo this section view, and I'm going to look at the topmost point of my threads. I'm going to mate that point right there with this surface right here, and I don't want them to be, oh, I selected a face, not an edge. So I'm going to delete that. I'm going to choose that point. There it is. So the point goes onto this face, because that's about where it would bottom out. Hit my green check mark. X out of that. And let's see how this works. Okay, so the threads are going in here, and of course this point almost gets to the bottom here, but I think it makes more sense for the threads to bottom out right on this face here. And the set screw is just inside this face here, which works out just fine. Okay. Now, of course, we would actually have to put the worm gear in first, but I thought it was easier to work on the set screw first. So let's go to Insert Component, Worm Gear, and notice how all of these are at least facing the right general direction. This one was opposite, but the front face was still all parallel with the front face of everything else. Okay, now I want to make the exact middle of the worm gear go right down the exact middle of this cutout. So I'm going to have to do an interesting mate. First off, I want to see I believe it's the right plane, no, the right plane of the worm gear. Yep, that's it. So I'm going to show that. And I want to mate it right in between here. But there's no regular mate that works with that. I'm going to try this Symmetric Advanced Mate. So that plane is right there. I'm going to try 2 other planes for it to be symmetric between. We'll see how that works. That one there, and that one there. And wow, it does look like it's doing just the right thing. Just on the other side. So let's mate up the center lines here. And this one here. Oh, I guess it didn't like that. That's an advanced mate. So for a standard mate, if I make them coincident, that'll be fine. And looks like I have exactly what I want. Yep, and even rotates like I want it to do. Now all that's left is to insert the adjustable jaw. And it came in a little bit wrong here too, but that's okay. I need to make this, which is the axis of this round part here. That's going to go to this. And then I'm going to change the mate alignment there. Of course, that's all screwy there, but that's all right. Then I'm going to mate the front plane of the jaw with the front plane of the handle, and that comes up very nicely. Now one more is needed. I need to mate these teeth with this worm gear. If you look carefully, they're kind of running into each other here. See, this can slide back and forth. But see that I've got a little gap there. If I move this around just a little bit, you can see that I've got a little gap right there too. Should not be quite any. Should be able to see just a little bit of daylight both sides. There it is. So there's not any interference required. So what I decided to do is make a tangent mate. So I'm going to go with this surface and that surface, see if I can make them tangent and see how that works. Okay, now this is proof it's going to be in the pudding here. Now there might be a little bit of interference, and that's to be expected, but I can at least simulate their motion here. There it is. Now I can slide that out, or I can take them back like this. It's hard to do and grab each one of these, so I'm going to remove temporary axes, see how that works. That's better. The problem here is that I may not have put the right ones together, so I'm going to just right click on this and delete it. Okay, now I can move this back and forth, and what I'd like to do is bring it pretty close like that, and mate, say, this on this surface here, so that it can travel along that entire surface all the way down, so it will have the greatest amount of travel. So let's mate that face on that one. So I want to make it tangent. No, it's still giving me those troubles. Make it tangent ahead of time. Click that face, that surface. Maybe it doesn't like it because it's not close up enough here. Oh, sorry. This is also the that flat side. So we'll try to take that face and that surface. There we go. Hit the green check mark and see how well that moves. Okay, so pull it down like this, and the jaw moves out. Keep pulling it down like this, and the jaw continues to move out. Okay, got reached the end there, it looks like. So I can keep pushing it back. And sometimes like one ends up grabbing the wrong side, so let's see if I can grab this, make it more consistent. There we go. Okay, so grabbing that surface there will be the most effective, and it can move all the way up and down. Okay, well that does it for this part of the assembly. I'm going to do a save as this, and then we're going to get into the motion study. As our experience with motion studies has shown, they can be a little testy sometimes. So first thing we want to do here is go to basic motion. Then coming along here, we want to put in a motor. We're going to put a motor in on this surface here so it can rotate. For the Geneva wheel, we used a constant speed going the same direction. In this case, we go back and forth, and so it doesn't make as much sense. Oh, you know what? I'm going to restart already. I'm going to kill this motion study. Well, I'll have to start a new one. But before I start a new one, I want to put my model in the position that I wanted it to be in. I've got to clear out of that, go to model, and we have to start this model right off in the position we want, and then start our motion study. Once we do that, the motion study will use whatever we started with on the model, and our changes to the model won't make a difference to the motion study. So I'm going to start at about here, and then I'm going to right click on motion study and go to create new motion study. Sometimes that's just the easiest thing to do because our clicks are usually pretty straightforward. So I go to Animation, Basic Motion, come across here, go to Motor Type. So I'm going to go right there. Thing is that when we used a motor for the Geneva wheel, we use this constant speed thing because you want the Geneva wheel to go pretty consistently. Instead, I want this thing to go back and forth. So I'm going to make an oscillating motor. Now, the default on this is 90 degrees. Well, this thing goes around what? We've got like 8 teeth times 360 degrees. So if I do 8 times 360, that's a whole lot of degrees. Well, might not need that many, so I'll just maybe do half of that, 1440. Quarter hertz means a quarter revolution per second. So that should give us 4 seconds for a full revolution. We can change that when we feel like it. And then this is an offset to start off with. We don't need that at the moment as a phase shift. Okay, so there are other options to go with, but that's the key thing we have to deal with here on the motor. And then we go to contact bodies, and we go from here to here, and that's it. Now, the assembly that we made might still work without this contact bodies thing. So I'm going to lay off on that for a second and just use the assembly that we'd already made. Then we're going to go to motion study properties, and in frames per second, 30. Oh, these are the defaults that I had from before. Let's see if we can make our processing time a little bit faster by reducing our accuracy and resolution. And the reason I'm concerned about this is because our parts are much more complex than the Geneva wheel, it's going to take longer for the computer to process it. So when I finally hit this button here, which is calculate, it might take a while. So now, because I chose not to use contact bodies, it might not be that bad, but we'll see. Oh, I also have to make sure that I'm going the right direction on the motor first, because I don't want it to be sliding that way. Okay, I think that's about right. So let's go to calculate. Oh, look at that. And that is the motion study for the Crescent wrench assembly. You could also have done it using a different set of mates and the contact bodies. That I've tried that, and that works as well. But I think doing it this way, it is pretty much as good as it can get, or just about as good. Biggest difference is, like I said, you look in here at our contacts, and it does look like there's some interference on some of these parts, whereas with contact bodies it would be a little bit more realistic, but on such a small level it probably wouldn't make a difference. So I can play that again here. And that is the Crescent wrench assembly, both with the ability to move it with the mouse and also the ability to make a motion study out of it that goes back and forth. The last thing I do is delete this old motion study, and then all you're left with is the model and the good motion study. So in review, we began a new assembly. We pulled in the Crescent handle. I showed you why to put it in with the front, top, and right planes instead of just bring it in fixed. And if you brought it in fixed and then you tried putting it up there, then it would give you a error because it was fixed. So you have to make it float, then put in those mates. Then put the set screw in, and I showed you how to use that section view. Now you can really see a nice section view of everything here. And that's why you want to use the assembly planes so that these section views come in the way you want them to. And we put that set screw in, putting that point right on that plane. Your application might need something a little different. And after that was the worm gear. And I showed you why I wanted to keep that worm gear nice and symmetric so I could use that mid plane, what we had as the right plane. And then we had a special symmetric advanced mate that put it right in between those two faces. Did very nicely there. Then finally we put the adjustable jaw on there. And the first two mates were easy. The last one, to make this face tangent with this surface, was not exactly obvious, but it worked out very nicely. From there we were able to make it go back and forth. And finally, to do the motion study, we used just that set of mates and then the rotary motor that was an oscillating one. And we had to use a lot of degrees here to make that work. And a quarter hertz seemed to work out right. You can make it go faster or slower if you want to change it up. Well, that is the Crescent wrench assembly video, and that concludes this particular tool. And I hope all of this helped.